it is 6, 7, and 8 is what we want, correct?
Yeah.
Okay, find a pen, find a pen, find a pen. So in 6, it is asking you want the hydrogen ion concentration. You have a solution that is... Say it again, Dan.
Do we want the hydrogen thingy?
Yes, because it says in question 6, it said
You
may not at ordinary level, but there is a possibility. So find hydrogen concentration of something that is a pH is equal to 3. So we know that pH is equal to negative log to the base 10 of your hydrogen ion concentration. So we now have that number, base 10 of your H plus. And if you want to find...
Is this in the pink book?
This is pink book. It's page 145. It's the worksheet that you had for homework. Okay, so what we are doing is then we have to get rid of the log. So we have to inverse log, and it's negative 3. So literally you press inverse log negative 3, and when you shove that in, it's going to give you 1 by 10 to the minus 3 concentration. Say it again.
Is the inverse log button on the calculator?
So I have a slightly different version of calculator. So but the inverse, where's the inverse?
It's 10 to the power of.
So my husband is saying that on your calculators, it's the 10 to the power of button that you press. I have. Can somebody help him? So in my calculator,
the log button.
It's the anti-log.
Shift log. There's the 10.
That's the one. That is the one. So in my calculator, it's second function log.
Yeah.
So yeah, but it's essentially the inverse of the log. So shift log negative 3. So does that work?
Yeah.
Yeah. Okay. I'm gonna erase this if that's okay. So that was question 6. So question 7 then, if we look at it, says you want to find the concentration of a sulfuric acid solution that has a pH of 2. So again, 2 is equal to negative log to the base 10 of your hydrogen ion concentration. So shift log negative 2 is going to give you your hydrogen ion concentration, which is 1 by 10 to the minus 2m. And then you just have to recognize that H2SO4 has 2 H pluses. So it is a 1:2 ratio, and you've just found out that your H pluses are worth 1 by 10 to the minus 2. So half of that is your concentration of your sulfuric. Does that kind of make sense? So you're inversing your log to find out your hydrogen ion concentration, but you have to recognize that in this example that what you found is the equivalent of 2 protons, and then you're working backwards. Are there any questions? With your permission, can I erase? So I can see Juno, Cam, Lucy, Sam. So I'm getting a thumbs up. I'll start from the top, and if you need down, shout. So there's no shouting. So that's that version. And then the last one, it says pH of phosphoric. So pH of phosphoric, should have written that as a formula. So it's H3PO4 that has a concentration of 0.04 m. So H3PO4 is the 0.04 m, but we want the hydrogen ion concentration to find pH. So you have to recognize that this is 3 H pluses. So it's a ratio of 1:3. So this must be 0.12 m in terms of my hydrogen ion concentration. And then I fill in my formula, and I get a pH of 0.9 something. 0.92.
Miss, for the ratio,
Yep.
I'm getting 0.013.
Well, for the ratio you can't, because it's the concentration is 0.04. It's a 1:3. 4 threes are 12.
Oh, I'm dividing by 3. That's where I went wrong. Yeah.
Okay, so it's
Yeah.
it's going the other way.
Yeah. That's where I went wrong. Thanks.
Not a bother. So I will still have a look at the ones that you have all put in your sheet. But for now, trying to find this part. So slideshow from Kurt. So is it okay to change my share? Take your silence as a yes. So Dan, this part is relevant for you as well. This is your last piece of maths. So in my book, in the pink book, we are looking at page 148. So we've done strong acids. pH is negative log to the base 10 of your hydrogen ion concentration, and now we have to figure out how we calculate for strong bases. So similarly to...
Mine's 149.
Say it again, Dan.
Mine's 149.
It is possible, because my book prints slightly differently to yours. I saved myself time by getting it printed. So it's the same rule as what we had for strong acids. Strong bases are fully dissociated. So it's a single arrow and you're turning them into its positive ions, but this is the base component, the OH. So again, it's the single arrow, so that tells you fully dissociated. So again, just like with the strong acids, you need to know the number of H pluses that are going to be in your formulas. So these are just some examples of strong bases. You could put in magnesium hydroxide is going to be a strong base. And then, oh no, I'm going to go here.
Miss, what page is this on?
So 149 is what Dan tells
It's
us.
the bottom of 147.
Okay,
1/2.
bottom of 147.
Yes.
So there's a QR code for 2016 paper at the top of the page, and we're halfway down.
Miss, when it says note the presence of a blank, what was there?
Note the presence of a single arrow. So the single arrow tells you fully dissociated. If it was a reversible arrow, it would tell you that it's only slightly dissociated. That's going to be a weak acid or a weak base, because it'll mostly be on the left hand side component, but some of the stuff on the right hand side of your arrow for weak acids and bases will be present. Now I'm just going to, you can't see, but I'm going to go out of this for a second. So you have a little table on your page. So it says base. So I'm going to change my share. Is that okay? So Lucy, I'm looking at you, and Cam, your heads. Thank you. So we have a base, we have number of OH in your table, and we have then concentration in 0.25 molar. So these are our bases. So you can now hopefully work out, if I have a 0.25 molar solution, what is my concentration of OH in each of these.
Cool drawing thingy.
Isn't it? I love this thing. It's a freebie though, so you get a limited number of slides, but it's cool. You know you're old when this
Freebie.
floats your boat.
Yeah.
Yeah.
Let's be glad this. And you don't have a paid software of this quality.
Well, you can get the paid software, but for the paid software, you have to pay them every month. It works out like $100 a year,
Shoot.
and there'd be no benefit to me. So I'll take my 3 free slides and just work away. So how many KOHs in KOH? How many OHs do I have?
1.
1. So therefore, then what is the concentration of OH minus in KOH?
0.25.
0.25. So are we all happy that NaOH is the exact same? The concentration of H plus is going to be 0.25. For MgOH2, what am I going to write?
1.
2.
2. So Lucy, you happy why it's 2?
NaOH.
MgOH2.
Oh, yeah, I get that.
Yeah, because it's this 2 here. So then what's my concentration of OH minus going to be?
0.5.
0.5. It's going to double. Okay. So we now have to work out if we have OH minus concentration, what is our pH? So when we've had the discussion about pH, did I say what pH actually stands for? I don't think that actually came up in conversation. So pH up here, pH stands for potential of hydrogen. It's how much hydrogen ions are in solution. So that's why the definition is negative log to the base 10 of your H plus concentration. But to be able to calculate pH, you have to calculate the potential of hydroxide ions present. So we have 2 formulas that we use. The first one is negative log to the base 10 of your hydroxyl ion concentration. And then once you have that number, you 14 subtract your POH. So the key for this one is if you're calculating a strong base, your pH will always have to be above 7. So if you do this first calculation, you might have 2 as your answer. So you will always have to subtract 14, take away 2 to find your pH. So the answer should always be greater than 7. Now, in both...
What's initio?
What's
Initial? Is that initial?
I don't understand the question.
You know, beside the OH. Is that spelled initial?
Initially.
Okay.
So last time when we did strong acid, we just calculate the pH directly, negative log base 10 hydrogen ion concentration. To do strong bases, we have to calculate the POH first. So we just swap out the H plus for this OH minus, and then we 14 take away the first answer. So it'll become clear when we start answering questions. So we have 2 questions left for everybody in the audience. I will.
You get a question. You get a question.
Yeah.
Everybody gets a question.
I'm glad, Dan, you have the Friday feeling. I do too. I'm just not as effervescent as you. Okay, so you're going to try this question for me. Find the pH of 0.1 molar NaOH. And I am going to
Now we have the formula.
yeah, so you now have got to use the formula. We're trying to find the pH of 0.1 molar NaOH, and the giveaway is that you have to know that this is a strong base. So if you don't know that, then you're never going to get the right answer.
Good point.
Thank you.
You're welcome.
Did Roisin ever get to us? I'll look at heads while I'm waiting. Yay, Roisin got to us. Hello. Ruth, you okay? You're already done? It was too easy?
Yeah, it was way too easy, miss.
Good job. I like your chandelier. I can see the shadow of it. It looks lovely. Alrighty, so we fill in what we know. in NaOH there's one equivalent of OH, so 0.1 molar NaOH is the same as 0.1 molar OH minus ions. When we do that piece of maths, we get 1, and then we take 14, take away 1, gives us pH 13. Okay, so the 2012 10B, I'll give you that question. It's very similar, it's not difficult at all. So I'm going to click forward if nobody objects. So that is the 2012.
I don't object.
Thank you very much. This is the 2012 10B. So calculate the pH of 0.5 molar NaOH. You should be fast and furious in how you do it, because it is easy. And I just need to check Teams. Teams, and see when your assignment is coming live. You are chemistry. Assignment. Okay, so just to look at this, so
How many decimal places should our answer be?
so this is one significant figure. Obviously, if it's a number greater than 10, then so this is what it would look like. So probably here, yeah, you would leave this.
Okay.
Because if you're rounding it up to 14, that doesn't help. So they will accept the 13.7. Now, Dan, that brings us to the end of our meeting for today. The assignment has pinged in Teams, and there are some questions in there for you to do. So you have until Sunday evening. I will send you a paper on Monday to start while we finish up our bits. It may take us 3 lessons, so the double and a single, but we'll stay in touch, okay? So I will make an assignment page for you it'll go to everybody, but it will just be for you to put up your paper as you go through it.
Okay.
All right, have a lovely weekend.
I will.
Bye. Okay, so everyone else, are we happy with that? Yeah, we have shaking of head. Okay, I just need to go backwards. So we're going to go backwards now. We're going to look at the higher level chunk of this.
Everyone leave now, or just me?
Just you lucky duck.
Okay. Bye.
Bye. Okay, so from current. And we now resume share. So we are flicking back 2 pages. So is it 144? Am I 2 pages ahead of you? So just 145, it says pH calculations for weak acids. So where are we on time? So we'll get something done. So going back to Arrhenius, weak acids slightly dissociate in water. If you are writing the equation, it will always have the reversible arrow in it. And in reality, because most of it exists as the ethanoic acid, that would be the size of the arrow. Equilibrium would really lie to the left-hand side in this. Okay, and the difference between the strong and weak acid is the reversible symbol. So the reversible arrow the reversible arrow is the difference between strong and weak. Okay, because all those moieties can be present in your solution. So because of this, the fact there will always be a dissociation constant, and it's called Ka for a weak acid, and for a weak base it's going to be called Kb. So the pH equation is slightly different, the one that you have to learn. So the pH of a weak acid is written like this: negative log to the base 10, and now we are square rooting the Ka and the it's called Ma. This is the exact same as your hydrogen ion concentration, or sorry, no, it's not. It is a concentration of your acid. So this, when I write this shorthand, it is negative log base 10 Ka by Ma. So Ka is your, what's called your dissociation constant. I think I probably have this written down. And Ma is your, so Ka is your dissociation constant. And Ma is your concentration of your acid. So you need to recognize in a question, it will specifically say Ka, and technically this is the only weak acid on your course. So those two things together tells you to use this formula.
Miss, is the M acid square rooted as well?
Everything is square rooted. Thank you, Holly. Yeah, it is all square rooted. So you have a 2004 question. It says, calculate the approximate pH of vinegar that contains 4.5 grams of ethanoic acid per 100. So you've got to find your way in, and you also have a value of Ka. So I'm going to go forward. So what's the way in? What's the first thing that you have to do? Or what's the thing you don't have directly?
Rules.
Exactly. So not quite, yeah. So you have to find moles. So what do you have to do with this?
Concentration.
Say it again.
Do you have to get the concentration?
You have to turn it into a concentration in grams per litre first, and then turn it into moles. Okay, so they like putting these little tricky little bit in, and for that reason then she can put more marks against it. So sometimes it's really straightforward, but you're nearly always going to have to turn grams per litre into moles per litre. So the answer that you should be getting is 2.43. So would you like me? I can currently see Cam, Ruth, Juno, Flo. Do you want me to start it, or are we still going? So you have to give me something, lads.
Still going.
Still going. Thank you, Cameron.
Miss, with the ethanoic acid, is that the CH3COOH or is that the CH3COO minus?
So what does your gut say? Sam, what would you do if it was in a test?
The minus one?
No, so the minus is the ethanoate, the minus is the salt. So CH3COOH is ethanoic acid.
What was that? Oh, okay.
No, go for it.
I was just asking what the answer was, but it's written down at the bottom.
It is. So did you get the right answer?
Yeah.
Okay, so I am going to put up for you below the assignment the questions that I want you to do. We'll go through this one. Questions. So it is going to be 20117D. So you only have two little small questions because they can ask weak acids and base questions a weird way. We need more time. So I'm going to start putting up the solution. So the first thing that you would do is 4.5 grams per 100 centimeters cubed is equivalent of 45 grams in 1,000 centimeters cubed. For your ethanoic acid is CH3COOH. So again, I would recommend that you show your examiner this working out. 12, 16, 16, 1. So when you add up, that comes to 60. So I'm now using my mass triangle to find me moles. So it's going to be 45 divided by 60, which gives me 0.7 moles per litre. That is my MA. I then have pH is equal to negative log to the base 10 square root of Ka by MA. And I now fill in what I have. So negative log to the base 10. I have 1.8 by 10 to the minus 5 multiplied by 0.75. And when I plug that into my calculator, I will get 2.43 as my pH. So everyone as happy as we can be?
Yeah.
Thank you for the feedback. Yeah. So the two questions that I'm going to ask you to do for homework are the question that's below it. So the 2011 7D question, there's two parts to it. There's a weak acid part and a strong acid part. So there's two parts to this. And 2012 10B, when you look at it, there is a weak acid part. So those have pinged under the assignment for you, and we will leave the other version of it until we have more time. Is that okay?
Yeah.
Yep.
So I have returned all of your revision exams. There is comments written on the paper and there is audio files. The actual mark scheme came attached to the assignment when it went out. I've just put it in as a reply to it. So if you have any questions, please ask. As always, check my maths. Because we found out this morning with Ruth that while I recorded it correctly in my mark sheet, I wrote it down differently in her paper. So always check my maths. And other than that, have a very lovely weekend. Get some fresh air. Hug your family.
Miss.
Yeah.
You know when you send in like a a link for the Zoom and it has accept or decline. Do we need to actually press that, or is that?
Yes, so if you accept it, what it does is it puts that into your calendar in Teams, and then it should ping you when lesson is starting, and then you can just click the link, or you can go into your calendar and double click on it and it'll come up and you can click the link that way.
Okay, thanks.
Alrighty.
I put into my calendar without me accepting it because other teachers told me not to accept it because it just gives them an email every time someone accepts it.
Oh, does
They
that,
also-
that's what's pinging away here in my background. I don't care.
Okay.
So-
Well, for me, it's in my calendar whether or not I accept it. So.
Okay, well that's it. If it's there, it's there. But I think if you do accept it, so does your calendar flash for you? Does it come up and say you now have this meeting?
Yeah, like 15 minutes before. And then
Okay, well then maybe you don't need to. I would always accept it if I'm going to, and I don't mind the pings. So lads, have a lovely weekend. We're 1 week
You too.
1 week down, so we're getting there. Alrighty, so I need to stop my share and then I can leave. Alrighty, lovely to see everybody.
Mommy.
Bye.
Thanks.
See you.
Mommy.
Yes, my love. Oh yeah, a mummy and a baby. Okay, I need 2